we've learned three different ways of solving quadratic equations. One of them by factoring and setting equal to 0 and using the zero product property. One by completing the square, and one by using the quadratic formula. So our exercise today is to solve three different quadratic equations using three different methods and kind of determining which method is the most correct to use to solve each of these equations. So I look at the three: x squared plus 7x minus 12 equals 0, x squared plus 8x plus 15 equals 0, and x squared plus 6x plus 7 equals 0. I'm going to select one equation to solve by factoring. Write that equation here, write down why I decided to solve it by factoring, and then solve it. I'll select another equation that I want to solve by completing the square, write the equation on this line, write why I decided to complete the square to solve that, and then solve it. And finally, the last equation remaining, I'll solve by the quadratic formula, write why, and then solve. So what do we mean decide why? Well, if I take a look at factoring, if I'm going to solve an equation by factoring, it has to be able to be factored. In other words, I need two factors of my constant that will add up to my b value. So if I look at negative 12, two factors of negative 12 that when I subtract them I get 7. It's negative 12, so opposite signs. So my factors are 1 and 12, 2 and 6, 3 and 4. Well, 12 minus 1, that's 11. 6 minus 2 is 4. 3 minus 4 is 1. This one can't be factored, so I don't want to try to factor this. 15. 1 and 15, 3 and 5. 1 and 15 adds up to 16. 3 and 5, though, adds up to 8. This one can be factored. So equation B, x squared plus 8x plus 15 equals 0. And I'll justify by saying 3 times 5 equals 15, 3 plus 5 equals 8. So let's go ahead and show the work now. I'll write the equation down. Remember, all of these cases I need to set equal to 0 to start. So I now see that I can factor the left side. Two factors of 15 that add up to 8, that's 3 and 5. They're both positive, so x plus 5, x plus 3. By the zero product property, I can write two small equations, x plus 5 equals 0, and x plus 3 equals 0, and then solve these. So, subtracting 5 from both sides, x equals negative 5, and subtracting 3 from both sides, x equals negative 3. So that's solving by factoring. I have two equations remaining, a and c, and looking at the two, if I'm going to solve by completing the square, my first move is to take the b value and divide it by 2, and then square that value. So if I'm going to divide the b value by 2, it's going to be much easier on me if that b value is even. In equation A, the b value is 7. In equation C, the b value is 6. So I'm going to select equation C, x squared plus 6x plus 7 equals 0 to solve by completing the square because the b value is even. Okay, let's solve it then. X squared plus 6x plus 7 equals 0. So for side work, b over 2, that's 6 over 2, that's 3. 3 squared is 9. So first, I'm going to isolate the ax squared plus bx term on one side. X squared plus 6x now equals negative 7. Now, b divided by 2 squared is 9. I'm going to add 9 on both sides. X squared plus 6x plus 9 equals 2. So here, x squared plus 6x plus 9, I used b over 2 squared on purpose because it creates a perfect square trinomial. This is x plus 3 times x plus 3. Another way to say that is x plus 3, the quantity, squared. Now I can take the square root of both sides. When I take the square root of a squared term, all I'm left is with that base that's being squared. So x plus 3 on the left side. On the right side, I have plus or minus the square root of 2. My last move here now is I need to subtract 3 from both sides. So x equals negative 3 plus or minus square root of 2. Nothing further can be simplified. This is my solution. So my last equation, only one that's left, is the quadratic formula. And so that is x squared plus 7x minus 12 equals 0. Why? Cannot be factored. B value is odd. So let's go to work with the formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So my equation, x squared plus 7x minus 12 equals 0. A is 1, b is 7, c is my constant, negative 12. So let's plug them in. X equals the opposite of b, negative 7, plus or minus square root of 7 squared minus 4 times a, which is 1, times c, which is negative 12, all over 2 times a, which is 2 times 1. Let's start to simplify. Negative 7 plus or minus, so I have 49, negative 4 times negative 12, that's positive 48 over 2. Simplifying inside the radical. 49 and 48, I get 97. So x equals negative 7 plus or minus the square root of 97 over 2. Now I look at this, and 97 is a prime number. I can't simplify this any farther. It has no perfect square factor. This is actually my solution. I can leave it in that form. Now, turn to the second page. You'll have the opportunity to repeat this process with 3 new equations. You'll get an opportunity to look at the 3 equations, determine which one can be factored, which one has an even b value, and then which one is most likely to be solved quickly by the quadratic formula.